Hey there everyone. So what we're going to look at today is we're going to measure the refractive index of light. And in order to do this, what we're going to do is you will have opened up the PHET simulation that you've got the link to on your Google document. You will have hit play and you've clicked the intro section. And what you're going to do is we're going to vary the refractive index. Now, first off, to change the refractive index, we can see the refraction happens here as I increase so I change the angle of this ray of light. We've got the angle of incidence, which is from the ray to the normal, and we've got the angle of refraction from here to the normal, from the refracted ray to the normal. Okay. Now this happens in water, and we can pick various different materials like so. What we're going to do is we're going to try and find the refractive index of a mystery substance. So the first thing I want you to do is click here and pick mystery substance A. And we're going to try and find what is the refractive index. Okay, we're going to try and do that by calculation. Now, we're going to take at least 5 different readings. And for the angle of incidence, the angle of refraction, and then from there, using the worksheet, we're going to calculate the refractive index of the mystery substance. So the first thing we're going to do is we're going to put a protractor right in the middle. So the 90 degrees is along the surface or the boundary between the air and the mystery substance, and that the 0 degrees is in line with the normal. So the normal is already drawn for us. And what I'm going to do is I'm going to start my refractive index having an angle of incidence at 20 degrees. Okay, we'll start at 20 degrees because it just makes life a little bit easier to measure. And so we can see that our angle of incidence, if we start from the normal to the incident ray and we count the degrees, we've got 10, 20 degrees. So that's our angle of incidence. So that's the first reading we're going to record in our table. Then what we're going to do is we're going to measure our angle of refraction. So our angle of refraction, again, we start from the normal and we measure to here. And our angle of refraction, my eyesight's very poor, but I'm going to say that's around 17 degrees. Okay, now you can be a little bit more precise than me. I'm just doing this very quickly. Okay, so my first angle of incidence, 20 degrees. My first angle of refraction, I've measured that really wrong actually, sorry, it's 7 degrees. Okay, 7 degrees, so yeah, 7 degrees. Then what I'm going to do is I'm going to increase the angle of incidence by 10 degrees, so I'm at 30 degrees. Again, angle of incidence is measured from the ray to the normal, and I'm going to record my angle of refraction. In this case, my angle of refraction, be careful not to nudge. Angle of refraction is from the normal to the refracted ray, and now it's 11 degrees. So I will record those two in my table. And what I'm going to do is I'm going to vary the angle of incidence at least 5 times. So I go from that down to 70 degrees. Okay. If I wanted to be more precise, I could maybe vary it every 5 degrees, like so. But it's really up to you. I'm going to say you need to vary it at least 5 times and that you have at least a range of every 10 degrees. Okay. Then what you're going to do is you are going to plot a graph of your results, a scatter graph of your results. But first, before you do that, you're going to take the sine of each angle. So you're going to measure the sine of, you're going to calculate the sine of each angle of incidence and the sine of each angle of refraction. And then what you're going to do in order to calculate the refractive index is you're going to plot a graph. And on the y-axis, on the vertical axis, you're going to have the sine of the angle of incidence. And then on the x-axis, or on the horizontal axis, you're going to have the sine of the angle of refraction. Okay, and then you're going to plot a scatter graph. You should find that that scatter graph has a straight line. So you're going to draw a straight line of best fit, and you're going to find the gradient of your graph. So you're going to find the change in height, divide it by the change in length of your straight line graph. And what you should find is that if you find the change in height by the change in length, that should give you the refractive index of the mystery material. Okay, right. Thanks very much, guys. Take care. I'll speak to you soon.